said no one ever. Domain for composition of functions. So here's what we got to look out for when we're compositioning functions, when we're doing a composition. So two functions, g of x is x squared minus 1 and h of x. What's the domain for g of x? So you're going to square it and subtract 1 from it, so what's the domain? Belongs to the reals, right? I can square any number and subtract 1 from it. H of x, however, what do we know about 2x, the expression 2x minus 6? What does it have to be? Greater than or equal to 0. So we've got to do a little work here. So we know that for the function h of x, the input to the function has to be greater than or equal to 3, right? So x is greater than or equal to 3, right? Otherwise, you're going to get a negative underneath the square root sign. That's bad news. Determine the simplified exact value of h of g of 4. Okay, so we're going to do this two different ways. First, by determining the value of g of 4 and then substituting. Okay, so what's g of 4? G of 4 is 4 squared minus 1, which is, just go straight to the 15, right? 15. So g of 4. Now, and then substitute the result. So what are we going to work out? H of 15. Right? So h of g of 4 is h of, and then g of 4 is 15. So h of 15, which is the square root of 2 times 15 minus 6, which is the root of 24, which is 2 root 6. Okay, so we work that out, we get 2 root 6. Okay, that's one way. Determining the simplified form of h of g of x, right? So it is possible to, like we have to do this 100 times, then we're going to say, look, I'm not going to work out the g of x and then substitute that in. Just give me one function that does it all. So h of g of x says what? It's going to be the square root of, so h of g of x. So h of x is the square root of 2 times, okay? So 2 times the input. Now the input is g of x, which is x squared minus 1, right? So it's 2 times x squared minus 1, and then what, minus 6? Okay. Is everybody good with that? Make sure, at each line, make sure that everything's, yeah, looking good. Okay, which is the square root of 2x squared minus 2 minus 6, which is equal to, so just carry on here, square root of 2x squared minus 8. Right? So that says, look, if you're going to be doing this a whole bunch of times, why not just work out the square root of 2x squared minus 8? Okay, and then substituting a 4, right? So we want h of g of 4 is equal to the square root of 2 times 4 squared, right, minus 8, which is the square root of, so it'll be 32 minus 8, which is root 24, which is 2 root 6. Right, and we say, okay, good. Yeah, I expected that because it's the same, right? It should be the same. Determine the domain of h of g of x. Okay, so what's the domain of h of g of x? Well, so if we look at h of g of x, this thing here, right? We're looking at the square root of, so when they say this, we're looking at the square root of 2x squared minus 8. Okay, so now we think, okay, so 2x squared minus 8 has to be greater than or equal to 0. Greater than or equal to 0. Which means well, we do this a couple of ways. What can we do? We could just say, okay, that means that x squared minus 4 has to be greater than or equal to 0. And we could just sort of, hey, x squared minus 4, that looks like this, right? It's down here at negative 4. That's a 2. That's a negative 2. So it says, look, if x is greater than or equal to 2, or x is less than or equal to negative 2, it's all good, right? Simplified form, right? I mean, it's like, you can mess with this. X squared is greater than or equal to 4, then x is greater than or equal to plus or minus 2, and, eventually we just come up with this. I think it's easier to just say, hey, that's a little quadratic, let's sketch it out. Here's my intercept, and it's got to be positive, right? So there we go, right? This branch here, this branch here. Determine the simplified exact value of g of h of 1 by, number 1, determining the simplified form of g of h of x and then substituting x equals 1. Okay, so now we're doing g of h of x. Good, so I'm just going to scroll down here, but I'm going to pull out my paper here. G of h of x. So g of h of x. So the function g says take the input, which in this case is h of x, and square it, and then subtract 1. Right? So g of x says square the input, subtract 1. In this case, our input is h of x. But we know that h of x is the square root of 2x minus 6. So we're going to square that and then subtract 1. So what's the square root of 2x minus 6? Quantity squared. 2x minus 6. So that's 2x minus 6 minus 1, which is 2x minus 7. Okay, nice simplified form, right? Works out nice and easy. We want g of h of 1, g of h of 1, which will be equal to 2 times 1 minus 7. Yeah, 2 times 1 minus 7, which is negative 5. Just sitting here looking at the key, which is a negative 6. I'm going, why? Why do you have negative 6? I'm going to go with negative 5. Okay, so what we did was we determined the simplified form of the composition of the function, used it to evaluate. Now, determine the value of h of 1 and then substitute the result. So h of 1 is equal to the square root of 2 times 1 minus 6, which is the square root of negative 4. That's a problem. So h of 1 doesn't exist. Now g of h of 1 apparently does exist, right? We worked it out. But h of 1 doesn't exist, so we should never have been able to put h of 1 into g, because the function g cannot accept a value of 1, right? We said that right up at the top. Oh wait, sorry, not the function g, the function h. Right? H can't accept a value of 1. We said that up at the top, right? Where we said x has to be greater than or equal to 3. Apparently this composition that we came up with could accept it, right? Why did that happen? Well, because we squared a square root. The problem is we know a square root that this input has to give you a value that is greater than or equal to 0, but it gives us a negative 4. So why are they not the same? One case we get negative 5, and in the other case we get does not exist. Okay? And the reason is the domain of h of x domain of h of x is x is greater than or equal to 3. So we never really could have worked out h of 1. Right? It's just because the function g said, hey, square this. Then all of a sudden the restriction on x disappears, right? 2x minus 6. Hey, throw anything in there, right? It's going to work. So we have to be careful. So in part D, you found that g of h of x was 2x minus 7, but you also found there's a restriction on the domain. State the domain of g of h of x. Verify with the graphing calculator. Okay, so g of h of x, what's a valid domain for that? So we know g can take anything, right? So then what's our restriction? It's just the restriction on h of x, right? It's the x values that are allowable for h, which is x is greater than or equal to 3. Okay, let's try that with the graphing calculator. Verify with a graphing display calculator. Okay, now, did this run into, somewhere it ran into a, using the graphing display calculator graph composition. Yeah. Okay, where is that? That's down at the bottom of the page, right? It says using the GDC to graph a composition. So to graph a composition of function, you're going to use the vars function, although maybe not. Turn on. Okay. So we're going to go to y equals, right? And we want g of h of x. H of x is the square root, so the square root of 2x minus 6. X minus 6. Okay. y2, that function is g of x is x squared minus 1. X squared minus 1. And to do g of h of x, we need to evaluate y1 at y2. Okay, so I want y1, so alpha f4, y1, bracket, alpha f4, if you have this, right? Otherwise, you know the drill. Vars, y vars. And number 2. So what I want is y1 at y2, right? So evaluate y1 at y2. Now to see that, we don't want to see y1 and y2, so we go turn those off. And how you turn them off? You just go to the equal sign and you press enter. And you'll see that the equal sign isn't highlighted. So an unhighlighted equal sign means it won't graph that. So all we're going to see is y3, which is y1 at y2. Okay. We wait for it. Okay, so do we have the domain, what do we say, x is greater than or equal to 3? Yeah, so on one side. So 2, okay, wait a sec. I had to type something wrong. Is that what you guys got? Same? 2x minus 6, x squared minus 1, y1 at y2. Okay, am I doing, wait, what are we doing? G, what are we doing? Are we doing g of h of x? G, so we should be doing y2 of y1. Sorry, got it backwards. G of h of x would be y2 alpha f4. I want y2 of y1. 1, 1. Wrap. Wrong composition. Okay, so here we go. There's your domain. X is greater than or equal to 3. Okay. I have now pre-done for you the other way around, h of g of x. Verify with the graphing display calculator. Yes, we can see that domain one more time. Here it is here. In general, the domain of f of g of x consists of the values of x in the domain of g for which g of x is in the domain of f. In other words, the outputs of g have to be allowable inputs to f. Okay? So the range of g has to be numbers which are allowable as inputs to f. Right? If it's outside of those values, then you can't put it in. Which means all we're allowed to do is put in an x value here that will generate this value such that it can be put into this function. Okay? Make sense? You can put an x in as long as g of x gives you a value that you can stick into f. We were doing super balls earlier, and it doesn't bounce very well. Determine a simplified expression for each of the following. You must take the domain into account when stating the expression. Okay, so open circle means composition, right? This is g of x. So I actually always like to just kind of write it out so I know what I'm doing. Okay, and I can't see the functions anymore. So g of x says take this input, which is g of x, square it and subtract 1. Okay, now the input here is x squared minus 1, so this becomes x squared minus 1 squared minus 1. Right, so g of x says, g of x, the outer function says take the inside function and square it, and the inside function is x squared minus 1. Okay, so we got x squared minus 1 squared, which is x to the 4th minus 2x squared plus 1 minus 1. This minus 1 is this guy here, right? So that'll be x to the fourth minus 2x squared. Now, is there any restriction on fourthing and squaring and subtracting? No, right? So x belongs to the reals in this case. Okay? It's like there's no value of x you can't give me that g of x can't handle. So there's nothing that I can put in the inside function that can generate something which can't be put into the outside function. Right? We can square anything and subtract 1 from it. H of x, okay, so h of x, so this is h of x, which is h of, okay, so now the input is square root of 2x minus 6. Okay, so h says take the input, which is this thing, take the square root of it, multiply it by 2, and subtract 6. Okay, so it's the root of 2 times the root of 2x minus 6. And this is the 2. It's just 2 times the input and then subtract 6. So that's the root of 2 root 2x minus 6 minus 6. And so for its domain, it's this one. 2x minus 6 has to be greater than or equal to 0. Means 2x is greater than or equal to 3, and x is greater than or equal to 3. No, that's 6, so that's 3. X is greater than or equal to 3. You think you get it right, having done it once already. But then this has to be greater than 0, right, as well, because it's underneath the radical sign. So this part is here, right? It says, hey, for here, x has to be, but then this part, so 2 times the root of 2x minus 6 has to be greater than or equal to 0. So 2 times the root of 2x minus 6 has to be greater than or equal to 6, which means the root of 2x minus 6 is greater than or equal to 3. So we square both sides, so that 2x minus 6 has to be greater than or equal to 9, and 2x is greater than or equal to 15, and x is greater than or equal to 15 over 2. So who wins? What's 15 over 2? It's like 7.5. So x has to be greater than or equal to 3, and at the same time, it also has to be greater than or equal to 7.5. So we just say what? 7. Yeah, we just say the more restrictive, right? X is greater than or equal to 15/2. So you want the most restrictive domain. It's like, yeah, sure, 3 is fine for there, but if you stick a 3 in there, you're going to have a negative 6 out here as an input. So I can't do that. Okay, right? You put a 3 in there, this becomes 0, this becomes 0, you just got negative 6 under a radical sign. So this is not restrictive enough. Okay? It has to be restricted, that this has to be greater than or equal to 7.5. That way this ends up being greater than or equal to 6, so this ends up being greater than or equal to 0. Right? Like ultimately this expression here has to be bigger than 6, or equal to, right? There it is there. Greater than or equal to 6. Okay, so the most restrictive domain. Okay, now, all right, what was 4c? 4c, that was h of g of x, right? Okay, so h of g of x is the other way around. What was this guy? This was h and this was g. Okay, so h of g of x will be y1 of y2. Come back. Turn on, okay. So that's one I originally did. So we'll go back to it. I'm just going to vars, vars, y vars, enter, enter. There's y1, and vars, y vars, enter, down arrow, y2, done, graph. So this was the less than or equal to negative 2, greater than or equal to 2. Right? That was 4c. So that was, what do you say, y1, h of g of x. And does the graph confirm? Yes. and then g of h of x. So you could do these, right? So all you're doing here is y2 of y2, 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 y1, y1. Okay, so that's just calculator stuff. And then this one we did, right? That was what? Is this something?
No, just can you show how you do this?
It's all in the recording. Yeah, it's actually at the bottom of this page. So you tell us how to do it. It says using the GDC to graph. Okay, it's in here. Just sort of skip through the first bit where I fumble around a bit, and then I get to the second bit where it's all okay now. Other examples. Oh wait, there's more. So we can do the inverse of functions, right? What do we do for the inverse of a function? F inverse. So I start off by just writing the function, right? So instead of f of x, I write y equals 5x minus 3. To do the inverse, what do we do?
X equals 5.
Yeah, you interchange x and y. So x is 5y minus 3. So x plus 3 is 5y. And y will be x plus 3 over 5. So f inverse of x. So that is a function, right? X plus 3 over 5 is a function. So f inverse of x is x plus 3 over 5. G inverse of x, okay, same deal. I just start out with y equals 2 to the x. That becomes x equals 2 to the y, which is y is equal to log what? Logs again? I thought we were done with those things. What's the base? 2, and the value we get is x, right? So that's the exponent, right? And what's a logarithm? An exponent. Thank you. One person remembered. So that's the exponent y, right? So y is equal to the log. Base 2, that's the base of the exponential of x. Okay. Now, is that a function? Yeah, log function. So g inverse of x is equal to log base 2 of x. F of f inverse. This is actually kind of neat, right? It's like, what happens if you do the function on the inverse of the function? Okay? So, if we're going to do f, so this is f of f inverse of x, which is f of, so f inverse of x is x plus 3 over 5. So I want to do function f to x plus 3 over 5. Okay, so what does f say? It disappeared off the top there. It says take the input, multiply it by 5. So that's equal to 5 times this input, x plus 3 over 5. And then, where are the rest? Where'd it go? What number is this? Oh, here we are, 6, yes. Minus 3, and then subtract 3. Okay, so 5 times this just becomes x plus 3 minus 3, which is x. Well, what if, let's go down and do f inverse of x, just because we just did the one order. So f inverse of f of x is f inverse, so f of x, wherever you see f of x, it's already defined, it's sitting on the page there. F of x is 5x minus 3. So let's throw 5x minus 3 into the inverse function. And the inverse function says take the input, add 3 to it, and then divide by 5. So take the input, take 5x minus 3, add 3 to it, and then divide by 5. So what's 5x minus 3 plus 3? 5x divided by 5 is x. So what happens when you take the inverse of the function, or you take the function operating on its inverse? What do you get back out? X, whatever you dropped in, right? So you drop x into your little function machine, you crank it away, and it throws out a value. If you drop that into the inverse function, which basically says undo this, it undoes it and gives you back your x. Right? Look, it's untouched. It's the same x you dropped in. Okay, what's going to happen with g of g inverse? So this is g of g inverse of x, which is g of, okay, so g inverse of x we now have defined, right? Which is log base 2 of x. Log base 2 of x. And g, the function g says, what does g say? 2 to the x. So we have 2 to the log base 2 of x. What's 2 to the log base 2 of x? What do you get when you raise 2 to the exponent? You would have to raise 2 to get x. You get x. Well, let's just evaluate it to x. We're not canceling it. Right? You're just saying that log base 2 of x is some number. What number? It's the number I raised 2 to get x. What are you going to do with that number? I'm going to take 2 and raise it to the power that I have to raise 2 to get x. So I'm going to get x. Okay, g inverse of g of x is what that means. So it's g inverse. Now g of x is 2 to the x. And g inverse is log base 2 of the value of 2 to the x. So what's log base 2 of 2 to the x? So log base 2 says 2 to the what gives you 2 to the x? X. So again, okay, now we shouldn't be surprised. We should be surprised that, hey, you left off a closed bracket. But we shouldn't be surprised, right? When we operate on x with a function and then we run the inverse, which just basically says undo this, we get back the x. Or in the reverse order. It doesn't matter what order you go in, right? So think of the function that converts Fahrenheit degrees to Celsius. You drop that in, and then you drop it back into a Celsius to Fahrenheit converter. You're going to get out your Fahrenheit degrees, and vice versa. So if the inverse of a function is also a function, then the inverse is denoted by f inverse. So f of f inverse of x gives you x, and f inverse of f of x gives you x. Okay, so if it's also, it's got to be a function though, right? Okay, here we go. Now we hit fun time. If h of x is equal to f of g of x, then state a possible. Okay, a possible. In other words, pick the simplest. Okay, expression for f of x and for g of x. So this function is saying take something, and square it. Subtract 7 times the same thing, right, and then subtract 6. And we want that to be a composition of functions. So we might say, well, the outer function is saying, so f of x is saying, take 3 times something squared, subtract 7 times the same thing, and subtract 6, right? That's the outside function. What's the inside function saying? So what are you going to throw in here that's going to cause this to happen? So what's g of x? 2x minus 5, right? So you have to look at is there's an outside function. The outside function is the f. And it's saying square some quantity, multiply it by 3, subtract 7 times the same quantity, and then subtract 6. So you say, all right, let's just let that quantity be x. So f of x is 3 times something squared minus 7 times the same thing minus 6. And then you look here and you say, but the thing you're squaring is this, so let's throw this in as g of x. And then h of x is now f of g of x, right? Because this now goes in here, and that gives you that. So now you look at this, h of x, and you say, well, what's the simplest function? What's the simplest f I could have? 3 over x minus 10, right? Now, what do I want to replace this x by? So then what's g of x? G of x will be 2x plus 9. What's f of g of x? Well, f of 2x plus 9, which is 3 over this, 2x plus 9 minus 10. Okay? So just make this simple. Just say, hey, look, that's going to be the input to my outer function, and my outer function is just going to be a simple. There are other possibilities, right? This is the most straightforward one. If f of x is 2x plus 1 and h of x is 3 minus 2x, then determine g of x such that f of g of x is equal to h of x. Then you got to say, really? What? What are we doing here, right? Well, we want, okay, so let's first do this. Let's just say what we want is this. F of g of x is equal to h of x. Okay, now we know what f of x says to do, right? F of x says, okay, let's go 2 times the input, which is g of x, plus 1, right? So f of g of x is the input. The function f says take 2 times whatever's in here, so 2 times g of x plus 1, and that's going to be equal to 3 minus 2x. Okay, now what we're going to do is solve this equation for g of x. So we're going to subtract 1 from both sides. So say 2 times g of x, we're not going to say well, but is equal to 2 minus 2x. So g of x is 1 minus x. Okay. G of x is 1 minus x, and that's your answer. Okay. If you went back and worked out f of g of x, you'd throw this in here, you'd multiply this by 2, getting 2 minus 2x, and then you'd add 1 and get 3 minus 2x. Okay. Number 9. If f of it's a fun because now there's 3 functions. And the first thing we're going to learn tomorrow is the fundamental counting principle, which is how many ways can you put 3 functions together? So here's the question. How many choices? There's 3 functions, f, g, and h, right? And when I say those, I really mean f of x, g of x, and h of x. So you want to put a function in first place, right? What's the first function? How many choices do you have for that first function if there's f, g, and h? 3. Okay, now, so we choose one of those. How many choices are left for the next choice of function? And then for the third choice, there's only, what's 3 times 2 times 1? 6. Good. We've now covered the start of the fundamental counting principle. I think that was on our outline, but we won't go any further than that. So there's 6 possible ways to, and think about it, right? FGH, FHG, GFH, FGH, FHG, GFH, GHF, HFG, HGF. 6. Right? I prefer HGF because you can go bigger and stronger with HGF. But I don't know. Human growth. No, it's HGH. Never mind. Human growth hormone. It's illegal. Don't do that. Yeah, you need to be like a really short kid, and they give you that. So look, 6. We are not going to do 6 because I don't feel like killing all of us or any of us. Okay, so let's just start with f, g, h of x. What does this mean? It means f of g of h of x. 2 words. Chain rule. They mean nothing right now. It'll mean something in like March. Maybe late February. I can't remember where we hit that. February or March, right? People are now thinking I'm dropping calculus. Okay. So we have f of g of h of x. Let's just do this one step at a time. F of g of. Okay, what's h of x? 4x. So the input to g is 4x. Okay, and we only need 2 parentheses now. What does g say to do with a 4x? It says to square it, so it becomes f of 4x quantity squared, right? So h of x says, take your input, multiply it by 4. Right? So h of x, wherever you see h of x, you can replace it with 4x. That's what the equal sign means. G of x says, whatever's in the brackets, I'm going to square it. Okay, so that's what we did, right? We squared 4x. It's 4x that's being squared. It's not 4x squared. It's really what? 16x squared. Okay? Now, what does f say to do? It says take the square root. So this now becomes the square root of 4x quantity squared. Okay? Which is, so we could work this out. We'll say equal. So that's the square root of 16x squared, which is, now you want to say 4x, right? But you really should be saying plus or minus. So here's a fancy way to say plus or minus. It's the absolute value of 4x. Okay?
I was about to say plus or minus.
Well, so what do you do when you have an absolute value? You make it positive. Okay? Because what do you have to do here? 16x squared has to be positive, but it's going to be positive anyways, right? They're going to take the square root. But the input, so now we have to look at like restrictions on the domain, okay? So going back to the original, there's no restrictions on this domain, right? You can multiply anything by 4. There's no restrictions on the domain of x squared. You can square anything. There are restrictions on square rooting, which is that it has to be positive, but it's going to be positive because you're squaring the x. Okay? So then x belongs to the reals. So essentially, let's try it out. Take a number. So take a number. Get in line. Take it. So let's say x is, let's pick something that has a, when multiplied by 4, has a square root. Let's say x is 16, okay? 4 times 16 is 64, right? So we make x 16, this becomes 64. It goes in here, and we now have 64 squared. You had to pick 64. That's, what's 64 squared?
4,096.
4,096. What's the square root of 4,096? Well, it's 64 because you just squared that to get that. Okay, what if x were negative 16? Okay, so x is negative 16, this is negative 64. We square negative 64, we get out 4,096. We take the square root of that, we get 16. Well, but we can't get 16 because we put in negative 16. So when we take the square root, it's really plus or minus 16, right? Because either one of those are valid inputs here, plus 16, minus 16. So when we square root something, we got to remember it's plus or minus. Here's how we can represent that. Say it's the absolute value of. Okay. All right. Let's do f of h of g of x. So again, outer function is f. So what I want you to start thinking about is the inside function, in this case, is g. You need to start thinking about this because of 2 words. What are the 2 words? Chain rule. I know, they don't mean anything yet, except for one of you in here. This means something. But you got to start at the inner function. Just remember this when you do chain rule. When do you stop doing the chain rule? When you run out of things to do. It's actually kind of easy, right? It's like, when do I stop? Just keep going. You'll know when to stop because you've just run out of things to do. Again, don't worry, this is months from now. Okay, this is f of g of, no, sorry, f of h of g of x. 2, 3. Which is f of h, now what's g of x? X squared. What does h say to do to its input? Multiply it by 4, so what do I write here? 4x squared, right? What does f say to do to take the square root of 4x squared? What's the square root of 4x squared? Plus or minus 2x. What's the fancy way of writing plus or minus 2x? Absolute value of 2x. Okay. If we take the absolute value of 2x, we're just saying we're going to make that positive. Okay. Now, restrictions. So again, start at the inner function. The inner function was g. Is there anything we can't square? Nope. We can square anything. Multiply it by 4. It's still going to be positive, right? We're going to take an input squared. It's now a positive number. We're going to multiply it by 4. Still a positive number. We're going to take its square root. That's fine because we know it's a positive number. So we can put anything in there. So x belongs to the reals. Okay. You can throw any number in there because ultimately it's going to end up as an input to a square root function, but before that it's going to be squared. Okay, g of f of h of x. G of f of h of x. G of f of, what's h? Take x So remember, this is my input to h, which is x, and then h says multiply it by 4. So we get 4x. What does f say to do that? So it's equal to, I'm going to kind of string them, but they'll fit better. So that's g of what? Take the square root of 4x. Yeah? Function. Wait, I've lost it off. Now it's really off the page. Online smart tech help. Don't want that. Okay, back. Back there. Okay, so f of x says take the input, which is 4x, and take its square root. So now we can start thinking, hey, there's a restriction, right? What's x got to be? Because you're going to multiply it by 4, that's cool, but then you're going to throw it into a square root function, so x has to be x has to be greater than, you think right now, hey, x has to be greater than or equal to 0 because I'm going to throw it into a square root function. Okay, now what's g say to do? It says square that. So we have the root of 4x squared, which is what? Just 4x, right? You're squaring a square root, you get back out what's underneath the root sign. Okay, but remember, the restriction is I cannot give f a negative value. And h of x could give me anything, right? If I throw a negative into h, I'm going to get out a negative. I can't put that into f. I have to give it 0 or greater. Okay, let's do g of h of... Okay, that's g of h of... What does f say? What does f say? What's that? Root x? Root x. Should be able to do the restriction right now, right? What's the restriction? X has to be greater than or equal to 0. Okay, so that's g of, what does h say to do? Multiply it by 4, right? So now we have 4 times the root of x. What does g say to do? Square it. So what do we end up with? 16x. As long as what? X is greater than or equal to 0. Right? Who's the restrictor of f, g, and h? F is the restrictor, right? G and H have no restrictions. They'll take anything. I can square anything. I can multiply anything by 4. F is to, wait a sec. If you want to work with me, you got to be positive. No negativity allowed. Got to be positive. Right? We got to be having fun here. Speaking of time, oh, we got time. We'll just go through. Let's just do the rest together. All right. H of f. Okay, give this one a try. H of f of g of x. Give it a try. Let's see how you're doing. So if I'm going to do this, I start by just expanding it, right? Like, yeah, you got your fancy notation with hollow circles. To heck with you. I want brackets, right? Like I need brackets within brackets within brackets. I need it as nested functions. That's really what it is, right? Okay, and you think by now I could remember what things do. So we've got h of f. What does g do? G squares it, right? Okay, what does f do? That square roots it. What does h do? That multiplies it by 4. Now, we're taking the square root of a square, which we now know is the absolute value of x, right? Because we can have a plus or a minus. Are there restrictions on what I can put into this? So are there restrictions on x? Because you're going to square it and then throw it in a square root, so it's going to be positive or greater than or equal to 0 when you square it, right? So there's no restriction on the x. It can be any real number. Okay. I can take any real number because the first thing I'm going to do to it is square it. Then I throw that into a square root function. You say, hey, it's okay because I already squared you, so now you're positive, right? Because I only work with positives, says that. Okay, and then we multiply it by 4. Oh, sorry, then we take its square root, and then we multiply it by 4. And lastly, h of g of f of... How far can you nest these things? As far as you want. Right? You keep going. When do you stop doing the chain rule? When you run out of things to do. This will make a lot more sense in a few months. Because right now you're just like, what's the chain rule? And if you looked it up, you'd just be going, I have no idea what you're talking about. Okay, h of g, what's f of x? I think I'd know by now. Root x, right? Okay, I'm going to, what does g do? So if the first thing that's happening is you're taking the square root of x, then you have to make sure that x is positive. Okay, then you're squaring the square root of x, you're just going to get out x. Then you're multiplying by 4, you're going to end up with 4x. Okay? Any question on these? Besides the general, this whole thing just went over my head. You're going to have to sit down and look at this. You're going to have to play with a few of your own. Okay? It will come. Okay? It will come. Trust me. Oh, look. A different 3 functions. Oh, but look. Now we get to do g. What's f? What's this? F, yeah, f of x times f of x, right? So don't get yourself in a mode where everything becomes this and you start seeing dots as circles. I think it's an open circle, right? Or I think an open circle is a dot, right? So first, there's any number of reasons for that. Reason number 1 is that 2-minute question on the test became a 12-minute question because you misread and you did a composition instead of multiplication. So take your time. I know, it's this fine balancing act on a test between taking your time to read it correctly, at the same time working through at a reasonable pace. But you should know, and probably have been caught at some point on some test by now, of when you weren't looking at it closely enough, you did the wrong thing and it became an unholy mess, which 20 minutes later you realized, wow, just got out of that rabbit hole, and so don't go down the rabbit hole. Take your time when you're first reading a question. Seriously, that's the most time to take your time on the question. Figure out what it means. So this is g of f of x times f of x, which is g of root x times root x, which is g of x, which is 1 over x. And what's the domain on this? So x has to be greater. So the first thing we're doing is rooting the x. So you have to be greater than or equal to 0. Except, do we want to change that? Because you're going to end up with 1 over x. So let's modify that and say that x is strictly greater than 0, right? Let's go back, get out the eraser, change that and say, oh, wait, I want to change that because I can see at the end it becomes 1 over x. So I'm going to change that and say that x has to be greater than 0. Okay, this guy is g of f of h of x. Okay, give it a try. What are you, teleporting? I didn't even see you move. Don't worry, this guy's like there, then he's there. I don't know who he is. Who is he? Oh, what are you an IB man? You're gonna be. Yeah, okay. That's how you do chain rule, right? Or you've heard of it. Okay. You do chain rule? When? Last year? Yeah. So you've done IB man? Yeah. You're just hanging here for. That's cool. Help these guys out. Okay. Yeah, it's like math is fun. Look, I'm here. I don't have to be. I did math a long time ago. Is anybody thinking about going to Waterloo? Okay, so Waterloo has a co-op program, right? Here, okay, hang on. Okay, G of F, now that we've had our little break. And then the other guy that dropped by is in second year, you'll see it. It's like, so what did you earn in here? Like, I had a summer job flipping burgers, you know. So, G of F of H of X. I have no idea what this guy did. G of F of X squared. What does X squared say to do? Take the square root of that. G of the square root of X squared, which we know is what? The absolute value of X. So it's 1 over the absolute value of X. So what do we know about X? What do we know about X? No. What can't X be? Can't be 0. That's it. So look, what are we doing to the X? We're squaring it. So we don't care if you're negative. Then we're going to square root you. Again, we don't care if you were negative or 0 even, you're okay. So now we're going to go 1 over, so you can't have been 0. If you were 0, we got problems because now you're 1 over 0. So X can't be 0. Okay? We can square anything. So right now you're saying X belongs to the rails. Yeah, X belongs to the rails. Oh, okay, but it can't be 0. Okay, ooh. F of G, what is this? F of, what's this mean? G of X plus H of X. Okay, so that's a sum, right? G plus H of X in real terms means G of X plus H of X. Okay? So this is F of, so what's G of X? It's 1 over X plus X squared. Okay, common denominator, put it all together. What's it become? What's the common denominator? X. How do we get this over X? So it's 1 plus X cubed over X, right? So you need X squared over X. To do that, you got to multiply it by X over X. Okay, and then what's F say to do? Take the square root of that, right? So it's the square root of 1 plus X cubed over X. Now what do we know? X can't be 0, right? If X is 0, we got problems right here. We got problems right here. Now, can it be negative? Well, okay. So we know that 1 plus X cubed has to be greater than 0, right? Greater than or equal, well, yeah, we can throw a 0 in. If 1 plus X cubed is 0, we're okay. So we know that 1 plus X cubed, or X cubed plus 1, so X cubed plus 1 is greater than or equal to 0. So X cubed is greater than or equal to negative 1. At the same time, we know that X can't be 0. So, okay, where are we here? So if you take the cube root of this, you'll get X. And if you take the cube root of this, you'll get negative 1. So it's greater than or equal to negative 1, but it can't be 0. All right, hang on a sec. So X cubed plus 1 is greater than or equal to 0. Okay, wait, yeah, you're right. So if well, hang on. If we throw a negative in here, we'll get a negative out. And if it's greater than 1, that's okay because we'll divide by a negative. Right? So a negative value for X cubed would be a negative. Add 1 to it. As long as it's still negative, we're okay because we'll divide by a negative. But if that's positive,
so it has to be greater than 0 or less than.
Less than negative 1?
Well, if it's negative 1,
So it can't be between
0
0
over
and 0.
negative 1. 0 over negative 1 is 0.
Negative 0.5, sure. That makes the top negative and bottom positive.
Well, okay, so if you had negative a half, this would be negative 1/8, which would be positive, and then you'd be dividing by a negative, you'd have problems there, right?
So it can't be between 0
So it can't be 0. Well, let's do this. 1 plus, how about this? 1 plus x cubed over x has to be greater than or equal to 0. Okay, so let's say that. This needs to be positive. Okay, now we know x can't be 0, we'll throw that. We'll worry about that in a minute, so let's just try and solve this. So 1 plus x cubed is greater than or equal to 0. Right, multiply both sides by x. So x cubed is greater than or equal to negative 1. So we got x is greater than or equal to negative 1.
Yeah, no, right. What you have to do is do 1 over x plus x squared, and then you just subtract, and then it gives you x is less than negative 1.
1 over x plus x squared greater than or equal to 0. Okay. So now what do you want to do from here?
And then subtract x squared.
Subtract x squared. Like so?
And then
It's the same thing.
Okay.
That's actually just the same thing.
So 1 is, negative 1 is, wait, I'm back to you. Okay, let's graph this and see what happens.
Oh, yeah.
Yeah, at some point it's just like, hey, I give up. Let's graph it. Clear. 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 Okay, what are we graphing? The square root of x cubed plus 1 over x. The square root of... Okay, square root. Okay, what do we got? 1 plus x cubed?
Like, what's the pixels percentage?
X cubed over x. Okay?
What's your
Less than or equal to negative 1. Just see if negative 1 is a value.
your hard drive?
Yeah.
No, the hard drive.
Okay, wait. So this would be greater than 0.
What about your
Less than or equal to negative 1 and greater than 0. Okay, but not equal to, because you'd be dividing by 0. Wow, that was a mess. Okay, next one.
I'll clear it.
I know, it's like, hey, we were done 20 minutes ago. Doesn't matter. Next one. If f of x is the square root of negative x, then determine f of x. Okay? So what's x? So x has to be less than or equal to 0, right? As long as you throw in a negative, then the negative will make it a positive and you can take its square root. Okay, so we want f of x. F of x. Which is f of the square root of negative x. So we have the square root of... Yep. Yeah.
I don't know.
The square root of negative x.
iPhone's better than he doesn't Yeah, but then if it's
Okay, so wait, here's the deal then. So, yeah, it's x equals 0, right? So what's the only number that's going to work? 0. So at first we say, okay, x has to be less than or equal to 0 to make this positive. Then we take its square root, which we know is positive, and we throw it in, and we've got a minus, and so the only number that's going to work is 0. Right? Put a 0 in there, you get 0, negative 0, it's just 0, square root of 0, 0. So it's just x is going to be equal to 0. You just say it.
the co-op.
If you graphed it, it's like all you would see is a point, right? If you graphed it and looked in the table, you just see error, 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 0, error, 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 error.
You get $8,000
No, you probably wouldn't get that.
a month too.
No.
Okay, what's next? 2 more. If f of x is root x and g of x is the absolute value of x squared minus 5, then determine f of g of x and g of f of x. What's g of x? That's value of x squared minus 5. Any restrictions on that domain? No, because the absolute value is going to make it positive. Okay, and if it's 0, doesn't matter. We can do the square root of 0. And g of f of x. So Goff is equal to g of f of x is g restrictions. Yep.
Do you have to show all this stuff if you can get to the last one?
Now, if you can get here faster, you can get here faster. If you get here faster wrongly, you'll just lose more marks. Okay? Like, I mean, in other words, you can look at this and just say it's g of f of x, so it's like going to square the square root of x and pi 5 and take the absolute
We
value.
have to break it around the
But x has to be greater than or equal to 0 because ultimately yeah.
Can you check like 1 minus cos squared x is sin squared?
Okay, wait.
G of x.
Hey, I'm still looking at the previous one to make sure. So fx root x, and then we're squaring that. Yeah. Okay, so for the next one, do what? Do 1 minus. Oh, okay. Next one's an equation we can solve. Yeah? Okay, come on, 5 minutes. We do this in 5 minutes. Pay attention. This could come in handy someday, like when's the test? Wednesday. Could come in handy. Wednesday, someday. Wednesday.
The only day.
Okay, 2 times f of g of x minus, so we've got this, right? 2 times f of g of x minus 1 is equal to 0. So f of g of x is equal to what? 1/2. Right? You're going to add 1 to both sides. You're going to divide by 2. Now, what's f of g of x? So we could do this in one swoop. So f says take the square root, and g, so it's the square root of 1 minus cos squared x is equal to 1/2. We can solve this. We got to square both sides to get rid of the radical sign. So we end up with 1 minus cos squared x is equal to 1/4. What's 1 minus cos squared? Sine squared. So this becomes sine squared x is 1/4. What's sine x? Plus or minus 1/2. Right? So you're going to square root both sides. The square root of 1/4 is plus or minus 1/2. So we want positive and negative, it's 1/2, so x is pi over 6 plus, it's going to be like n pi, well, it's sketchy. So that's pi over 6, that's pi over 6, pi over 6.
Five or six plus or minus.
Well, oh wait, what's the easier way of doing it?
So you can spill it way too.
So,
It's amazing. Like,
Oh, yeah.
So the other way, so you can do it as pi over 6 and 5 pi over 6, or you can just do it as plus or minus pi over 6 plus n pi. Okay. Done. Done. Look,